So I think it's time for to start our roundtable and discussion. Maybe we can start with a quick round of questions that you may have to specific speakers that presented today. And after that, we can share some concepts like the one of occlusions or image quality that rises during the presentations and during this event as main issues of effectiveness and precision or to apply AI to the fishing sector in the different environments we analyze. So maybe if you have any question to any of the speakers, so please raise your hand and go ahead with them. So Thomas have one. Please introduce yourself very quick and go ahead with your question.
I will. So, so hello everyone. I'm Thomas from Sadling, Spain, and my question was, it is for Justin because referring on this tool to identify the setting and the hauling operations, because I know very well this problem because we work with this. And my question is, you mentioned you were using a machine learning and for this. And my question is, which data, if you can tell that, I don't know, maybe it's some special source that you use, but which data or how much data are you using to identify all this to create your data set for these machine learning techniques?
The data set was around 1,000 hauls, 5,000 sets from a longline fishery in British Columbia. So that's the only place that we've trained on, and that's the only place that we've tested on as well. But we're collecting more data from different fisheries that Archipelago is involved in. So there's sort of similar but different challenges in like trawl fisheries and the sensor data that they collect.
Okay, that's I don't want to push anymore because I know that this could be very, secret or whatever, but the size of the data set, I believe it's useful for us. So just to say congratulations to you, well, and to everyone that has presented, because the presentations were very instructive. So thank you very much.
Okay, thank you, Thomas. More questions? Sebastian, please.
Hi everyone, so I'm Sebastian. I'm a PhD candidate and project manager at Fish ID. I have a question to Matt and pretty much everyone. Matt Dawkins, that is, sorry. I would like to know what are your thoughts on tools like Viame that have a paid subscription behind it. In Australia, we have seen that there's a huge push now to make open access software now paid subscriptions. And obviously that conflicts with software like Viame that's all open access and you can access it at GitHub. And I myself have used it before. So I'm just curious to hear your thoughts about if you see that industry going ahead and how does that compete with open access software?
And Kitware as a company, we try to push open source software just because it makes collaboration a lot easier. And I think a lot's domain context. Some in other industries it might make more sense, but in this industry, the ability to share data easily, have other groups use others' data, I think is pretty important just for bootstrapping model performance and things like that. So I'm hoping it doesn't go in that direction. Viame itself, we're definitely not going in a paid direction. It's a open source piece of software, and we're not changing that. But I think a lot depends on the domain, and I guess who's making the training data is another source. I mean, the algorithms are one thing on the software platform, but a lot of these large data sets, a lot of people will put a lot of time into it. So some people are very amenable to posting them in the public, others are not, and they want to keep them private and restrictive. A lot of that depends on the application as well. electronic monitoring versus fishing applications versus underwater applications and government censuses. Each domain has its own little quirks where the same thing might not necessarily apply to all of them, but I'd still hope that these things can still be as open as possible.
Okay, thank you, Matt. More questions if you have. I think Ignacy had one for Nuria at the very beginning of the forum regarding to the quality and the how standard mass the photograph have to be, no?
Yeah.
So maybe it's the time to to perform it. So the Nuria, if you are here, Ignacy asked at the beginning the chat how standard must the photograph be, and could this work be done with underwater pictures? So if you want to answer him.
Yes, we use photographs from both angling and underwater, but what I meant by a standard procedure is that we collected photographs from different projects during different years, and it wasn't until the middle of the project that we define how the photographs should be. And for example, if it is underwater, that we can see all the mosaic pattern of the individual, and if it is from an angling photograph, that we have to be careful with the shadows, so the model can adapt to both the scenarios, but we should follow like the same procedure for all the photographs. But as we collected all photographs, so we had this problem.
Okay, and do you conduct a pre-treatment of the pictures before you enter them into the training, or not? I mean, do you apply some filters to the pictures before analyzing them?
We cropped the background of the image with Photoshop, and that's why I say we could apply segmentation techniques in the future, but no other adjustment.
Okay, right.
Okay, thank you. That's one of the main problems is regarding to apply all these AI algorithms and deep learning, machine learning, whatever, is the quality of the images in all the scenarios of the fishing chain. Both underwater with the turbidity or the lining could be a problem, or on board with the weather condition if we are using REM systems, for example, in long lining or in long liners, or in our case some condensation that could borrow the images. So I think this is a very important issue to have a good quality images to properly train and define our algorithms. I think it's a common problem to all the environments or working places to apply your ideas, and I think it's one of the things that we have to take into account for good results, a good precision of the algorithms. So Andres, please go ahead.
Okay, I think, can you listen to me?
Yeah.
Okay, thank you. I am Andres from University of Alicante. I have a short question to curiosity to Angelo. I'm not sure if he's here in the audience.
Yes, I'm here.
Hello, Angelo. Hello.
Hi.
Congratulations for your presentation. I like it a lot. We are a group working in computer vision in Alicante, and we have experience using RGBD cameras with depth cameras. And I have listened in your presentation that you have used this kind of cameras to try to improve the measure of the weight. And yeah. I think that the volume of the fishes, and we are thinking about, nowadays we are only working with RGB cameras, but we are thinking about to incorporate our knowledge with RGBD cameras to try to improve our measures of the length and the volume of the fishes. And I want to ask you about your improvements using this kind of cameras.
Yeah, the point. Can you hear me? Huh?
Yeah.
Yeah. Okay. Yeah, we are integrating the results that usually we had, for example, in phenotyping. So you have a fish, you have to extrapolate features for the genotyping. So for more for the, and in this case, you have just one fish, and the volume is the best way to calculate the weight. And of course, it is easy. It's one fish. So starting from that, we applied the idea that indeed it's still in development, but it's working very well, is the fact that if I know from my database that I have a fish with a length that has to have also a weight. So in principle, what we are doing until now, so dimension of 2-dimension, linear dimension, and we get an extrapolation of the weight. If you are integrating also the volume, and we can first, have an information more because we have more data for that. So in principle, it's more precise. The let's say the error of the inaccuracy is less. Second, if I have an overlap, and I have that from this species, I expect a kind of weight, but the volume is larger, is telling myself that there's something under this fish. And usually you see, for example, I have in the presentation as shown, you have overlap of two fishes. It's pure a chance for that. To means that at least I can extrapolate some weight from that. It's for me very important because if I have to calculate the whole discard and in the weight of all discard, also if I commit some errors, it's still better than have the calculation of the 10% of the discard from the human observation. So let me say that it's really something that get more. And of course, we also don't forget that the fish is maybe up of some debris on the fish, and a lot of other situation of the fishes at the side of conveyor belt. So this increase a lot the information that we have about the weight, so really putting extra data, but also solving some basic problem of decision that we have at the end of, let me say, of the processing. Let me say a kind of post-processing. In the moment that we have some uncertainties and we have this computational volumes, we can decide with that, and it is in principle is done with machine learning, that weight is a composition of two weights of two fish, and the calculation has to be taken account. Or perhaps if you can detect that is debris on the side, it's just one fish. So it's the computation is correct. That is the main idea that we are using, and this is also why we want. I show in the schema that we are doing assemble of neural networks. We are not using only one algorithm. We are using together because, of course, the problem is complex, and the occlusion is one of the most complicated stuff that we have to handle in the visual inspection, and sometimes it's in this case it's not possible to move the camera, so you cannot really see around the fish. So it's something that we think that is one of the way to improve the quality of this. And okay, that's it. I answered your question.
Oh, perfect, Angelo. Thank you very much. I think that these kind of cameras, RGBD cameras, are also improving and are more and more cheaper, and can be very useful in this field. Thank you, Angelo.
You're welcome.
Okay, thank you. Justin, you raised your hand. Please go ahead.
Yeah, I had sort of a follow-up question on the RGBD cameras. I'm curious if anybody has experience deploying them out at sea, and what are the challenges of using those versus RGB cameras in the field.
Angelo, I think it's for you.
Yeah, I think it's for me. Okay. Okay, start with the fact that you have a stereo camera. Of course, the stereo camera, let me say, we can use different technique. Well, in this case, we use the disparity map for calculation the volume. Of course, if you have no, let me say, pattern, the disparity map can give you very bad results. It's the first challenge. Second, we use that because we are using the projector on this is the reason why also we protect a lot the conveyor belt with the diffuse light, etc. We use a projector for the pattern of the fish, because of course in situation where the fish is flat, you saw that almost that fish is flat, and you have also water, you have a lot of let me say, situation where the pattern is complicated, you have to use a projector. But of course, the point is, if you use a projector in non-protected environment, let me say with, let me say, open, let's say the natural light, of course, you neutralize the pattern of the projector, because, the natural light has also the frequencies of the projector itself. So this is one of the basic challenge that you have with the stereo system in this way. If you have a system with more, let me say, patterns, so you have more differences. Let me say, the deep, the stereo camera that you have inside, for example, a net at the end, I think that's a very fantastic system. The fact that you have fishes of round fish moving in the background give you more, let me say, possibility to detect the depth more than in situation where you have a conveyor belt. Still, also conveyor belt give a lot, but there you have water, and use a laser can be very complicated. There is a lot of other possibilities in the stereo, but depends also what is the way to use, let me say, let's say the system to create this pattern. And what you can say more? In this case we use a very cheap camera, because it's very compact and it's everything we can put very close to the conveyor belt, because it's you can stay almost around 40 centimeter, and this is very useful because the quality is very high. In other situation, you know, if you use larger distance, the camera has to be larger, because the baseline has to be larger, and it depends of the application what you need. The point is that until now we are using, at least now we had this approach, for example, it's more for the software. We using this the third, let me say, the depth, like let me say in Vimea, like sensor fusion, really using the extra information and also to post processing. It will be very nice if you can use, for example, 4-dimension. So really the fourth dimension in a deep learning images. I know that there are a lot of groups that are trying this, but until now, the best way that we could have to evaluate the weight was using this like post-processing and using like extra information. And I hope that I answer your question.
If you let me jump in, there's last summer we developed a machine learning system for detecting mango fruits in the field, and we were using RGBD cameras. In fact, we were using the InterRealSense, the same one that Angelo is using, and I was surprised that when I got the camera, the first thing we did was try it out outside under the sun and see what happens. And as opposed to previous RGBD cameras, these turn out to work pretty well in short distances. But then I found another limitation that Angelo, because Angelo mentioned already what happens if you go farther. You are projecting a pattern that is infrared. In the ambient light, you might have infrared, and then this might affect the quality of your point cloud. But I found another problem because we were developing a robot that would cut a mango and pick it from the tree, and these cameras are using USB 3. And this is not an industrial standard. And as you start making the cable longer, you start having problems with the signal that you're getting. And for that reason, I have a couple of projects now in which I'm using RGBT cameras, and I'm using Ethernet, PO, power over Ethernet cameras that are, it's like, industrial standard, and then you can make the cable longer, you have less frames that drop. We integrate everything in ROS middleware, and then you have for this embedding of putting things in a system that you want to use for processing. I save a lot of headaches by using more industry standard protocols in this sense. So I just wanted to add on that.
If I may just adding, indeed we are using the Framos camera because it's indeed an Ethernet. So he has this conversion to USB and Ethernet because otherwise it's impossible. Really, in the fish environment, in the sea environment, it's really not possible to use this camera at once. And indeed in robotics, because we are using a lot of also in robotics. Short distance, it works very well, but larger distance, it's you have a lot of waste. Loss of data, indeed.
And now that we were mentioning this, Luis, I have a question for you about for the Dalsa camera that you showed, the linear camera, the Teledyne Dalsa. Are you putting it in a housing so far, or?
We have an IP 68 or 69 car case to protect it because the marine environment, as Angelo said, is it's too hard to Sahara's environment. So we are using an IP protection for the camera.
And are you suffering from condensation because of the heat?
At the moment, no. Maybe my colleague, Juan Carlos, that is my colleague that is working with that on board. I think that we have no problems with condensation at all at the moment. Juan Carlos, can you confirm that point?
Yes, we hadn't any problem in the test we had in the Oceanographic Vessel.
In fact, sorry to interrupt. In the first version of the IO server, I am Carlos Vilas, and I am also working with Luis Taboada and Juan Carlos in this project. In the first version we have of the IO server, we have some problems with condensation. So we use a Peltier cell to avoid the problem, and it worked quite well, even in the marine environment.
Okay, then let me give you a hint. From the robotics, from the underwater robotics side. In many cases, we are putting these bags of silica that you get when you buy some electronics equipment, and we put them inside the housing. In all our housings, we have pressure sensor and temperature sensor, but for small housings, just putting a silica bag is enough to
like the one that you find in the shoes when you buy some shoes. That's
same type.
That's
same
correct.
type.
It's a good fit.
We buy bigger ones, and then we cut them and staple them so that they fit in the place we want to put. And for condensation,
that's a great solution and cheap solution. That is important.
In fact, we use one of that, a little one, but only by chance maybe, but it works.
That's very good.
Okay, more questions from your side? I have a list here, but I prefer from you. If you have any questions, I can give you the opportunity. No, so Rafael, I'm going to give you a question. It's not a revenge, okay? It's only it's very interesting for us, and I think for our colleagues from the Spanish Oceanographic Institute that are also present here, your deep vision system that you are trying. For what species or trolling fisheries are thought about the design? Because for the for Nordic fisheries of cod, for example, you have only one species. But if we wanted to apply this kind of device in mixed trawlers here in Galicia, for example, where you can find in a whole 20 different species, how precise could be the division system could be?
So the idea is that this is designed, as you said, for the North Sea, in which you're trawling, you want to go for cod, for instance, and then you want to be sure that that thing that you see in the sonar is actually caught, instead of doing a trawl of 5 hours and then discovering that you have catched something different. So this is intended in this sense. Because the opening and closing of the gate is not fast. So this gate that allows the fish to go out is just because you pre-program the idea. This is not yet implemented with the processing on board, but that's the target. It's to have the target species. The skipper is going to say, okay, I want this target species with this specific size, and then I start the trawling. And if I'm catching what I want, the gate will be open and will provide feedback to the skipper saying I'm open. And otherwise, it's going to close the gate, and it's going to notify the skipper that this is a trawling which you're not catching what you wanted to catch. But I should say that what I showed is the one that has been implemented, deployed, and is being commercialized for research institutes so far. This is not the industrial. There's a second version that it's been developed, which is the industrial version, and it's going to be a lot lighter. It's going only to have like the camera system that I showed with the housing and a foil that goes on the other side of the net, and it's going to be a lot more flexible with the lights, with some LEDs on the sides, and the idea is that it's going to be something that has to be a lot more robust and less bulky than the research device that I showed. So, but
that sounds good.
Trawl in trawling operations in which you have only one species or two species entering the net.
Okay.
But in the long run, we want to have these statistics running. So at the end, it would be also something that could be used in places where you have more heterogeneity and get these statistics, give these statistics before you remove the whole, so that you can get some feedback on what is being catched.
Okay, thank you. One of the ideas of this roundtable also was to discuss among all the participants, researchers, companies, and whatever, the constraints that the application of this AI, the AI applications or technologies that we have developed during our research and our work to the fishing sector. So we have pointed out some hints or some issues. One I commented you previously that as we could see during the presentation was the occlusions problem and the overlapping, because we are working with images, and if the images are not of good quality, and even you have the problem of fishes one over the others, and we are not working with X-rays camera. So I think one of the main problems we detected in all the applications, in all the fields, even underwater, on board and on shore, are the occlusions. I don't know if you agree with me on this topic, but it's a quite difficult problem to be solved, and I think it should be solved in a case-by-case application, but I don't know what is your opinion about it. Okay, you are all... you agree with me? Now, the point that...
So you want... I can make my point if you want.
Yeah, sure, Andres, please.
Okay, of course, I think that is one of the most important problems, because if you can't see the whole fish, it makes it difficult to to try to identify the species. In our case, we are working in a fish market that is a small fish market. And as you can see in our presentation, the occlusions between the fishes are not so large. Then what we are doing is only use data augmentation techniques to try to improve the image labeling, but maybe in the future when we face a more complex problem with more overlapped images, maybe we are going to have to introduce new techniques, maybe using information about the context, about the neighborhoods, and questions that nowadays we are not using. I think that is one of the biggest challenges here.
Yeah, that's one of the questions that you introduced now, and Rafael also mentioned that we are working also in our iObserver to introduce additional data to the fishing catch. We have an application that gets the info of the position of the GPS, of the speed, of the depth of the trawler, called Redbox, to integrate or to reference the fish catches with that very interesting information that can be used to provide further information or valuable information to the fishermen. I have one question for you, Andres, that I forgot to make you. You told in your presentation that you use a software, a Django labeler, for fixed segmentation. How is the performance of this kind of software? Are you satisfied with the results? Because we are doing it manually, and as you know, it's a very hard and time-consuming step and work. And I wanted to know how is your experience with this kind of softwares?
Yes, I think that this is good experience. It's not really an automatic segmentation, but it's an approximation. What you can do is to put the bounding box over the fish, and the Django labeler make the segmentation, and it makes a good segmentation. And then you can improve. You can manually try to improve the segmentation, and then you do the labeling. But Django labeler makes you easier because I don't know if I have explained it. So you put over the fish the bounding box, and Django labeler make the automatic segmentation. And our experience is that this segmentation is really good. We don't have to make a lot of manual improvement of the segmentation, and this is very interesting in trying to save time in order to make the labeling.
Is one thing our to-do list to try this kind of software to avoid this manual and tedious operation of fish segmentation, but it's great to hear from you that you are satisfied with the results that provide this kind of tools. Let's try it in our projects, and thank you. And Ignacio raised his hand. Please go ahead.
Yeah, I just have a comment on the problem of occlusion. I think like there are. This problem is very context specific, so I get that the problem of occlusion in underwater images is different from the problem of occlusions that you may have on land. And in our case, for example, we have an easy situations in the auction, in the fish market, because actually our species is classified by the fishermen in boxes where you only have one species. It is true that we have this problem that Amaya showed with the occlusion, but in this case, because we have the metadata of the weight of each of the boxes, then we can infer actually the number of fishes that we have in the box through the weight. It is not a straight relationship, even if you have the length-weight relationship, because you have to take into account that the large fish contribute more to the average weight of the box, so you have to do some non-standard corrections in there. But we are quite happy with the method because you can extract the actual number of fishes, which is one of the key variables for stock assessment. Not only the average length, but also the number of the fishes landed. So, I mean, in that specific case, occlusion can be treated statistically if you have the weight and the boxes contain only one fish species. in the case of underwater images, I guess that if you are dealing with one dominant species and you can have an idea of the volume of the mole, of the volume of the school, then you can also treat it statistically by trying to infer through iterative estimations of the number of fish that circulate and the volume of that school. But also it's very context specific, I guess.
Yeah.
So an internal problem, I guess.
Yeah, I know. It's not the same the fish movement, like one fish only jumping in the conveyor belt of a fishing vessel or a dead fish in a box. I know, but maybe a similar or a common solution for this kind of occlusions or statistical filters or whatever could be applied to these different, quite different scenarios or case studies. So that's the idea.
I wanted to add another problem that we face is when you don't work on videos but on just on images, and you have some fishes that are close to the camera. So you have to set a threshold for in which you say, okay, this fish is possibly occluding the view of other fishes in the background. So treating this statistically is not easy at all.
No, I know.
With this kind of yeah.
For sure. Thank you, Rafael.
So when working in a conveyor belt, this made me think of this project. You see, if the case is that you have two fish together, this is an example of an industrial inspection system we developed for a meat company, in which you have this conveyor belt, and you see there's a gap between this conveyor belt and the next conveyor belt, and we have a vision system that is inspecting this using linear cameras on top, and then we place two cameras on the bottom too. And you see, of course, that there's some liquid and some remains going on. This allows us to have a view, in this case, of these, in this case, hamburgers from the top and from the bottom. And this gap is for the linear camera to inspect from both sides. Of course, you need to put a conveyor belt on a tilted angle because you want gravity to drop the water down. But this is just this made me think of similar systems that we have had, in which you see this is the inspection from the top, the inspection from the bottom. But in the case you have overlapping, if you only have two overlapping fish, this is a good way to identify what you have.
Yeah, this is a perfect solution in the case of industry, but in the case of a fishing boat, to introduce a camera in the bottom of a conveyor belt, that's one of the other points that I have annotated here to share with you and to discuss, because maybe to improve the efficiency of this kind of technologies and REM systems and whatever, maybe we should do some modifications or redesigns on the fishing parks in order to maximize the efficiency and the precision of the estimation that our AI-based systems made. Maybe if we change the position, the angle, or the, in our case, for example, if we modify the velocity of the conveyor belt in different sections with different velocities, we can avoid somehow the problem of overlapping. If you put some physical barriers also. So maybe that's another point that we should comment to our fishing vessels or our fishing fleets, that maybe a next step or an additional step that we should take is to make some modifications or some redesigns in these fishing parts in order to maximize the value of the data we are obtaining with the REM systems. I think it's one point that I always wanted to carry out in our projects, but due to we have no money or the fishermen are not very, likely to or they want to make some work in his vessels is quite complicated. So
they want to have it as short as possible, but of course shaking and vibration.
Yeah, vibration systems that's the point.
To a faster conveyor belt for sure will spread.
Yeah, that's the point. we wanted to avoid the big mountains amounts of fishes, but if we have a moderate overlapping, as I showed you in the presentation, the results are quite good. If you combine some kind of these new designs or technologies, hardware technologies in the conveyor belts, maybe our systems could be operated or give more precise and malleable and information about the catches. So that's my point of view, and it's one of the points I also wanted to share with you. So it's also the fundamental of using a linear camera, Rafael. We wanted to try in our quite different environment, like the fishing fleet, the fishing vessel, the use of linear cameras that are widely used in the industry, for sure, and they operate quite well. But here in the fishing vessel, we are having the problems of a precise synchronization with the movement of the conveyor belts. It's been a quite hard work, but we think the future should go in that way, to collaborate with the fishermen and to make the vessels and the environments more friendly to our AI solutions. I think that's my opinion. I don't know what you think about, but we need the fishermen involvement to achieve the success of this kind of new developments and new technologies in helping the fishing sector.
May I add
Yeah,
something? Oh, sorry.
No, go ahead.
No, go ahead.
No, it is indeed one of the solutions if you have mechanical separation, and of course you have the second lane scan that you can see in the bottom, and it's a spread, is the best solution. But usually what we have in a vessel is that we have a little space, and it is the very, actually is the only problem, because fishermen are very willing to do this kind of application, but if you have 8 meters of 10 meters of conveyor belt, this also separation pieces, it's very difficult to achieve. And drilling too, and of course in the sea also drilling, it's also a big issue. But, and of course also just to put an encoder for the lane scan is sometimes complicated, because of course you have to modify a very large part of the conveyor belt. But I agree, if you can mechanically solve a lot of problems, like also with the breeze, big stones as to move it mechanically before that come to the conveyor belt, you have a lot of problem already solved. But indeed, as to what we have to push, I mean, it has to come with the new boats. This concept that part of the space has to be used for the mechanical separation. My point of view.
Mm-hmm. I agree with you, Angelo. You have a lot of work done if you could implement this kind of additional measures to our AI solutions and systems. And another point of view of the collaboration of the fishermen, for sure, that we need. Then, for example, is one is for Chris. I don't know if you are there. It's regarding the video you saw with us, because it was very, very instructive that we need the collaboration of the fishermen. But in the video you can see only one part of the discards that the fisherman is generating in that video, because he throw up the fishes on one side that you can't see it, but you can see in the other side, the other way he was throwing the fish. So we need for sure the collaboration of fishermen, maybe changing their own practices on board, but it's quite complicated. But they are changing their minds on that. But for sure, we need that collaboration in changing some kind of fishing operation or fishing rituals or habits that they have in order to improve also the efficiency of our solutions on board. I think your video, Chris, was very representative of that. Even if we install REM systems like the one that Justin showed up, or Archipelago Marine Instruments are implemented, or Sunlink, because if you have outside cameras, but you have a fisherman, right, making an occlusion of the fish you are taking out of the sea, there are some, some habits that you should improve or have in order to maximize the efficiency of our systems. That is my point of view. You have to get involvement, the full involvement of fishermen in order to get good results and a good performance of our systems. So I don't know if you agree or you have any experience or that you want to share with all of us. Okay, that's my point of view. I hope you.
Well, I'm not sure if Chris is still here, but I could chime in a little bit. Is Chris still here?
No, I think let me check. I didn't check the. No, he's not. He's not connected. But it was a very representative video of what are fishermen practices on board somehow.
Yeah, and I'll just chime in and say that I agree with you wholeheartedly that getting the fishermen, trying to get them on your side, I think is really important. And I don't know much about how these monitoring systems get implemented in Spain, but in the United States, we have basically councils that are associated with each fishery, and it's really hard to pass regulations around monitoring without their support. And I think there are issues like you're mentioning where sometimes the regulation goals are misaligned with the fishermen's goals. And so why would they agree to have additional monitoring if it is a headache for them and it doesn't offer them any operational benefit? So yeah, I think it's a complicated open question. How can you pitch these technologies to the fishermen in a way that's like, this is going to improve your life while also, meeting these other management and regulatory objectives, because then you can get them, putting the camera in a way that helps you make better sense of the data and things like that.
Yeah. Here in Spain, the level of implementation of this kind of EM systems is still too low. There are some fleets, long liners with this kind of system implemented. And yesterday, the government of Spain publicated a kind of grants or to implement this kind of technologies on board to facilitate the fishermen to pay for that, for implementing that. So it's increasing the level of implementation, but it's still too low. And for sure, for me, and for all of us, I think is the implication of the fishermen on its application and their acceptance is required and is a key factor to improve the level the level of implementation of this kind of AI solution that we explained in this forum. Oscar, please.
Hello, everyone. And before I forget, thank you to the organizers and all the participants. The presentation were amazing, really enlightening and interesting and very clear, so congratulations. And now answering a bit about this real experience, or real programs experience in Spain. As Luis is saying, at the moment it is low, but it's increasing step by step. In fact, there's some fishery associations, especially in the longline fisheries, especially the pelagic longliners, that are doing really good efforts to implement EM. So right now, especially the EM systems are installed as a complement for the human observers on board. So in cases where the vessel cannot place a human observer on board, they're using the EM. So it's more like kind of scientific coverage, not compliance, not control. So this is more the case, and especially in the super seiners, the fisheries, the tuna super seiners in the Indian Ocean and the Guinea Gulf, they are also carrying EM systems. So step by step, we are increasing the coverage. There are some trawlers, especially due to the interactions with dolphins, as the case in New Zealand. You know that there's a high sensibility on this issue and this matter. with the dolphins, the Maui dolphins, or there in the Bay of Biscay dolphins. So they're installing even in bottom trawlings. There's a voluntary initiative for having more data and document all these interactions and all this accidental code, and especially with these trawlers. Okay, so as you already mentioned, the collaboration with the crew is crucial in this for DM and the image recognition. If you don't have a good illumination, if you don't have the clear lens, it's nothing. You can have the best model of the world and you do nothing. So at the end, you always depend on the crew when the system is there on their own. So regarding the Spanish initiatives, since I think a couple of weeks ago, or 1 month ago, UNI, the Normalization Association, released a document with a standard, a proposal of a standard for the EM systems in Spain. So trying to clarify all these, data requirements. Okay, so going step by step, fishery by fishery, explaining which fields need to be covered for a scientific report. So it's a kind of aid for the fishermen to implement EM systems on board. So for example, for the gill nets, it states, okay, for the gill net, the areas to cover are this and this and this, and the cameras should have this and this and this characteristic at least in order to have a data of quality enough for the reports. Okay. So it's more or less the update of the
of the situation.
So
okay, thank you, Oscar.
Thank you very much.
You are more of
congratulations.
As a company like Marine Instruments you represented, you are more in the the updates and new releases of the legislation and regulations, and thank you for this information. Angelo, I think you raised your hand also.
Yes, just to add the Netherlands experience, let me say, and also the Belgian a little bit. Of course, the collaboration, it's the most important thing, because it's otherwise you can have a system on board, but somehow it never work. You know the story, and if they don't accept the system. But in Netherlands is, let me say, starting to accept the fact that it's a future. They have this system on board. The story is try to change the idea of control and punishment with the idea, okay, have an opportunity to manage the data. So this is the aspect that in Netherlands we are trying also to bring it. The fact that we are saying obliged registration and not obliged landing is it's one of the aspects. I mean, you have to control your discard, but means also that is for you an improvement in the less consuming, for example, fuel, because you are not putting your net in a place where you have too much discard. It's something that has to be integrated in more political and also interesting for the fishers, let me say. And for another, I'm talking about the trawler in this moment. So it's difficult for, if you are in a workspace, just to put the fish at the side. It's really complicated. So one system that stays at the end of the conveyor belt, it's enough usually to catch the whole information. Other system, I don't know, but the pelage system is, like also in Netherlands, is very interested to use a lot of this monitoring, because the amount of the fish is larger, and they wanted to have it inside, so they are more positive for this. Yeah, we are working, you saw for the presentation, with the fisher union, because otherwise it's impossible to get something. And it's really also to put the camera on board. It's if the skipper say no, it's no. You cannot put it inside. That's it. Thank you.
It seems that happening everywhere the same. Without the fishermen and the okay from the fleets, it's impossible to implement any cameras, any new AI solution or whatever. So I think that's one point that we should keep working with that and try to involve fishermen from the very beginning of our projects to cover the problems that they should or they could have during their activity at sea. I don't know if someone else have any additional question or whatever. Because if not, it's 5 minutes to the end time of our session. So if not, I'm going to thank you again for your participation, for speakers, for attendees. It was, I hope it was a fruitful forum for all of us. Maybe we have some contacts. For sure, I'm going to contact some of you with our problems, and I hope it's the beginning of a nice and fruitful collaboration in the future with meeting some of us. And I want to thank you, especially the speakers once again from the US, from New Zealand. And Chris is not here, but for their effort on participating on that. On this forum, and if you don't have anything else to say, please, thank you, and have a nice day, and we keep in touch for sure. You will receive some news from us very soon. And if you are not, you have any problem, we want to publish the videos of the presentations in our SICAPTOR 2.0 YouTube channel, and we are going to be available to remind and to share with your collaborations and with your companies and receive your colleagues and whatever. Okay. Thank you so much to all of you.
Thank you very much, Luis and everybody.
Okay. Bye-bye.
Thank you very much.
Bye.
Bye-bye.
Thank
Bye-bye.
you.
Bye.
Thank you for inviting me.
Thank you.
SICAPTOR, monitorización electrónica para una mejor gestión.